Hello, my name is Kyle Thompson.
I'm Flynn Yoder.
And I'm Jose Terrazas.
And we're here today to talk to you about our senior design project, the Tetris Clone for KEC Engineering Center Installation.
During this presentation, we're going to be introducing our project, going over the engineering requirements, having a brief overview of the block diagram and the subsystems of the project, giving any unique design concerns, and having a timeline for the completion of our project.
Basically, our project is to make a large-scale arcade machine with the intent of playing the classic Russian arcade game known as Tetris. However, we are not limiting our project specifically to Tetris. We hope to expand the game library further beyond that. In addition, our arcade machine will be put in KEC Engineering Center, so hopefully it will be a source of student entertainment as well as a source of education so that students can learn from the hardware and software aspects of our project. Also, it needs to be a piece of playable art, so it needs to fit in with the aesthetics of KEC Engineering Center.
As stated before, our display is going to be quite large. This is needed so that it provides a good user experience as well as being easily viewable. Even though the display is large, the resolution is going to be quite small. This resolution will be at least 20 pixels tall by 10 pixels wide. This is the resolution needed to play Tetris. However, other games will be bounded to this resolution. We want the user experience to be enjoyable. To do this, the operation of the system needs to be fluid. Because the operation of the system needs to be fluid, we have a few requirements on the connection events for the different subsystems. The display must be recognized as connected within 5 seconds, and the disconnect event must happen within 1 second of the actual disconnection. When this disconnect event occurs, the operation of the program must halt until the user reconnects the display and tells it to continue. The controller event is very similar, but the numbers are a little different. It needs to be connected within 10 seconds and disconnected within 5. The memory interface is quite different. We need to be able to read off of it within 15 seconds of connection, but since we don't want a disconnect event to cause system failure, we'll be copying the game files into temporary memory. Another aspect of the user experience is the gameplay itself. Because we don't want to limit the player to only Tetris, additional games will be available to the user through the use of the external memory interface as long as the game files are valid. Some of these game files may be multiplayer in nature. We want to provide full support for multiplayer games. In order to do this, we will have multiple controllers to be used. The controllers used will have at least the 4 cardinal directions and 2 push buttons to support classic arcade games. Also, the interface used for the controllers will be standardized to allow multiple controller types. Because the user experience is so important to our project, we want to make sure we get ample user feedback. To do this, we're going to create a survey that addresses at least the following requirements. The first requirement is that 7 out of 10 people must say that our user interface for the system is intuitive. Another is that 9 out of 10 people say that with a specific game in mind, they would be able to go up to our system, pick up a controller, select the game, and begin play within 30 seconds. A third is that 7 out of 10 people say they would be able to study in the same general location as our system.
Now let's take a look at the top-level block diagram for the Tetris machine. From a high level, this is our project. Our implementation requires 2 different enclosures and power supplies, 2 microcontrollers, at least 2 game controllers, and the LED array display. Our project solution will reside in 2 different enclosures, the podium and the display. Because of this, there will be 2 separate power supplies, 1 for each enclosure. Both power supplies will need to provide 5 volts DC to their respective hardware. However, the power supply of the display will need to source much more current because it will need to power the large quantity of LEDs in the LED array display. The system will operate based off of user input to the controllers. All of the controller data is sent over USB connections to the main control unit, which will proceed to process the controller data and perform the appropriate actions. The user will also have the ability to connect an external memory unit so that media can be added. In order to start the process of displaying data, the display information will be sent over a UART channel to the secondary microcontroller. From there, the data will be processed and sent to the LED array display using the serial peripheral interface. The user will then receive visual feedback based upon the displayed information. The main software execution will be represented by this flowchart. Upon initialization, the main microcontroller performs all of its initialization routines. It then proceeds to search for games in internal memory and, if present, external memory. At this point, the user is able to use the controllers to interactively select a game to play. Once a game has been selected, the game is loaded and gameplay starts. The game ends either when the user pauses the game and chooses to quit, or the game ends normally. The user is then prompted with the option to either play the same game again or return to the main menu. If the system is inactive for an extended period of time in any of the post-initialization software states, the system will enter a low power state. The software for the secondary microcontroller is relatively simple. It needs to receive data over the UART channel and retransmit that data on the serial peripheral interface. One very important function that this microcontroller will need to do is respond to the data that is being sent to it. This will allow the system to fulfill the requirement of sensing when the display disconnects.
In this section of the presentation, I will be talking about the unique design concern. The first unique design concern is the screen. As mentioned previously, the screen needs to be 7 feet tall by 3 feet wide. If the screen was made out of computer monitors, it would cost several thousands of dollars. Because we are on a limited budget, we need to seek a cheaper alternative. A less expensive alternative is making it of LED arrays. Our second unique design concern is our video transmission. Because we plan to use wireless, our concern is the speed. Wireless transmission tends to be slower than wired ones. We are also concerned about the environment. The environment might obstruct the signal. In general, cost of wireless transmission is more expensive than wired ones. Finally, our third design concern is the location. Because Kelly is a place for students, the Tetris Clone might be a distraction to the students trying to study. Kelly also has limited space, therefore finding a place to put a screen that large might be a challenge. Kelly is full of natural light, therefore the screen might look dim on sunny days. This is the basic timeline of our project. Over following winter break, we plan to have completed the design, build a prototype for the LED arrays, purchase the controllers, and written the main code for the project. During winter term, we plan to come together and review the design and make any necessary changes. We also plan to build subsystems for the main project. Midway into the term, we plan to have the project completed to better prepare us for spring term. Over spring term, we will document the project, make any extra improvements to the project, and prepare for the expo.
Again, my name is Kyle Thompson, and I gave a brief project overview. Our senior design project must be a large arcade machine that at minimum plays Tetris, the classic Russian arcade game. It also needs to be visually appealing, and we're going to put it in Kelly Engineering Center.
Once again, I'm Flynn Yoder. I went over the different engineering requirements for our project, the size and resolution of the display, continuity of the user experience, the different aspects of gameplay, as well as the importance of user feedback to our project.
I also gave a top-level overview of the block diagram of the electrical subsystems of our project, as well as the top-level flowchart for the software of our project.
My name is Jose Terrazas, and I cover the unique design concerns and the timeline for the project.